Hello, I am Theorem I and this is my YouTube channel. So here you will get mathematics and science lesson videos, difficult concepts made easy through well explained and thorough methods of teaching. To get notifications from this channel, subscribe, like and share. Share to your neighbors, share to your friends, share to that student, share even as a parent to other parents. Alright, who have students and children in secondary education. I want to assure you that you are going to get lessons that appeal to the understanding of your words, of your children, of your students, and even you as a student. Thank you. You're welcome again to today's session of maths and science lessons with Olali Combat Boss. So today we are going to continue our sessions, we'll continue our lessons, alright, on circle geometry. And today we are learning to state and prove the following circle theorems. The first one is that the angle at the center, the angle subtended by an arc at the center of the circle is twice the angle at the circumference, at the remaining part of the circumference. Again, the angle subtended by an arc at the center of the circle is twice the angle at the circumference, the remaining part of the circumference. And the second is that the angle in a semicircle is 90 degrees. The angle in a semicircle is 90 degrees. And the third is that the angles in the same segment are equal. The angles in the same segment are equal. Alright, let's dive into it quickly. Alright, so all you need to do is to just pay attention, alright, as I take you step by step, alright, step by step on how to prove this. Alright, so it is not sufficient to just know how to state, alright, it is important that you know how to prove the theorems, right, quite important. Alright, so let's start with this. So we draw a circle. So here we have a circle center O, alright, we have a circle center O, and as we have been doing before, right, we have two radii, alright, and then an arc just in the middle, an angle just in the middle. Alright, so we have center O, we have arc AB, let's call this AB. Alright, so we first want to prove that the angle subtended by an arc at the center of a circle is twice the angle at the remaining part of the circumference. Is twice the angle at the remaining part of the circumference. Now take note that AB is an arc, right? And AB is the minor arc, right? Is the minor arc. This is the minor arc. Then the remaining arc in the circumference is the major arc, right? Is the major arc. So here, all right, you see that. So AB is an arc, right? It subtends an angle just in the middle, right? I mean at the center. Let's call that theta. Let's use it as theta. All right. As we go on, for the sake of explanation, we are going to see more on that. So now let us see. AB is an arc and it subtends an angle at the center, which is theta. Now this is the remaining part of the circumference. Now angles. Let me first say this, that angles are formed at the vertex. Angles are formed at the vertex. What is a vertex? A vertex simply is a point where two lines meet. Now, even though we know, right, that the sum of angles, right, at a point is 360 degrees. That is, angles in a circle can all come together to meet at a point, and that's 360 degrees. However, angles can also be formed in other parts of the circle as long as there is a vertex. Angles can also be formed in other parts of the circle, right, on the circumference, in other parts of the circle, basically, right, as long as there is a vertex. So here, what we are going to do is that we are going to form an angle. We are going to form an angle just at the circumference. So let's say we have an angle here. All right. So let's say this is X, right? This is point X. So you notice that at point X, right, there is a vertex. So what that means is that there is an angle here. So theta is the angle at the center, is the angle at the center of the circle, O, while x, right, is the angle at the circumference, at the other part of the circumference. Now, how do we go about this? We want to prove that the angle at the center, which is theta in this case, right, is twice the angle at the circumference. Now, how do we go about this? Now, one thing about geometry is that you are allowed to reproduce, right? You are allowed to extend, you are allowed to, to reproduce, to draw, to add figures, to add lines, all right, to shapes, as long as they are part of the rules. You have to follow the rules. So here we have radius AO, we have radius BO, right? And so here there is this point at the circumference. So how do we go about it? Now I can draw a line, right? Now a line from, let me say something again about geometry. That anytime you have figures, you have shapes, right? No matter how it looks. Now, there are theorems that are pivotal, right? And there are certain shapes that are pivotal, right? To explaining geometry. One of those shapes is triangle, right? A triangle. Now, before now, you must have been taught, and maybe subsequently, we're going to release a video on triangle theorems. Now, pay attention. There are two basic triangle theorems that every student should know, and one is very popular. The sum of angles, right, in a triangle is 180 degrees. The sum of angles in a triangle is 180 degrees. Now the second one is that the exterior angle, right, of a triangle is equal to the sum of the opposite two interior angles. Is equal, the exterior angle of a triangle is equal to the sum, that's the addition of the two opposite interior angles, that's opposites to the one outside. But that's just another lesson, right, on its own. But I hope that we'll be able to, we're going to release a video on that. Now look at this clearly. So like I said, in geometry you are allowed, you are at liberty to extend, you are at liberty to reproduce or even to produce, right? So what I've done here is to draw a line. As long as whatever you are doing helps you to explain and understand what you're doing better, right, you are allowed to draw. And as long as you also obey the rules of geometry. Now, so I've drawn a line from X. Now this line, right, you can see I'm using a fainted line. I've drawn a line from angle X, right, also down to cut through theta. So I'm going to, because it is cutting this, right, let me use the angle here as P and the angle here as Q. The angle here P, the angle here is Q. Now I can also divide these two. Let me say that let's say this is X, small letter X, and this is Y. So the line that I've drawn has divided these two angles into two. So this is X, angle X, and this is Y. So angle X and Y are the angles at X, right? Capital X. Angle P and Q are the angles at O, the center of the circle. Alright, so what do we do and what do we notice from here? Now, if you pay attention closely, you will see that we have two triangles, right? There are two triangles here. So we have triangles AOX, and BOX, right? BOX, and you can name it, you can either say AOX, AXO, it's the same thing since we are describing the triangles. So there are two triangles here, and another thing for you to take note of now is that a line that is drawn from the center of the circle, right, to any point on the circumference is a radius. We have seen this before. Now look at this. This is O. OA is a radius. So let's say consider triangle AOX, right? Consider triangle AOX, you see that AO, this is AO is radius. AO is radius, right? You also see that XO is radius. XO is also radius. So out of the three lines, right, AO, XO, and AX, three lines of a triangle, two of them are equal. Now that should ring a bell, right? When you have a triangle and two sides are equal, what kind of a triangle is that? That's an isosceles triangle. Isosceles triangle. So we can say that triangle AOX, consider triangle AOX isosceles. So this will help our explanation. Triangle AOX is an isosceles triangle. Is an isosceles triangle. So AOX or AXO is an isosceles triangle. So what that means is that XO is equal to AO. Now, what again do we know about an isosceles triangle? The base angles are equal. The base angles of an isosceles triangle, right, are equal. Now, if you consider triangle AOX, right, AOX. Now, where's the base? AX is the base. AX is the base, right? So, where are the angles at the base? The angle at X and this angle at A. So, if this is X, right, that means this also will be what? Will be X. Right? So, consider triangle AOX. AO is radius, XO also is radius. Two sides are equal, which makes it an isosceles triangle. So here, let me also include this. I'll say that the angle AXO, that's the angle at X. AXO, right, is equal, right, to this angle here, XAO. XAO. And what's the reason? Base angles of isosceles triangle. Base angles of isosceles triangle. So if this is X, right, that means this is also what? This is also X. Right, I hope that is clear. Alright? If this is X, the angle here, the angle at A, because X and X here, they are the base angles, right, of the triangle AOX, right? I hope that is clear. Now, let us move to the other triangle. Consider triangle BOX. So, from what we have explained here, that makes triangle BOX also an isosceles triangle. How do we know that? The line that is drawn from the center of the circle, right, to any point on the circumference is a radius. So this is a radius, OB is a radius. I think did I write that? Okay, no. OB is a radius, right? OX is also a radius, right? OB is a radius, OX is also a radius. So that makes two sides of this triangle equal. So that is also an isosceles triangle. Isosceles. So triangle BOX is an isosceles triangle. So if triangle BOX is an isosceles triangle, okay, we also apply the way we did earlier, that the base angles of an isosceles triangle are equal. So if this, and this is the base, right, BX is the base. BX is the base of this triangle. Here, AX is the base of the triangle. Here, BX is the base of the triangle. So this is why, right, the angle at the other end of the base, right, is also Y. So, Y here, that's base angles of an isosceles triangle. So let's put that down. So we will say that OBX, OBX, that's the angle at B, right, which is Y, is equal to OXB. OXB, alright? Or you say XBO, right? BXO. That's the angle here, and that's equal to Y. What's the reason? Base angles of an isosceles triangle, right? OBX is equal to OXB, which is Y. base angles of an isosceles triangle. So now, what is the implication of all of these, that we have done? Now, don't forget, we want to prove, right? We want to prove that the angle at the center, which is P plus Q, is equal to two times the angle at the circumference, x plus y. So this is what we want to prove. We want to prove that the angle at the center of the circle, subtended by this arc AB, right, P plus Q, is equal to twice the angle at the circumference. The angle at the circumference, x plus y, right? These two angles, they form the angle at x, right? So it's twice the angle at the circumference. So what again do we need to do? All right. Now just pay attention, all right, and don't be lost. So listen to this. So what again do we notice, right? Now again, I'm going to say this and I'll keep resounding it. That in geometry, right, your ability to see, right, is important, right? Your ability to see, okay, you have to be able to look closely, all right, to see, your ability to see, what can ordinarily, not be seen. So you have to pay attention, and for you to be able to see those things, you have to really pay attention, right? You have to pay attention and be quiet. Now, look at this. With all that we have done, right, this is what we want to prove. We want to prove that P plus Q, right, is 2 times x plus y. But then how do we go about that now? Note that P and Q, right, both of them together, they are the angles subtended at the center of the circle by arc AB. Alright? But then you will see that angle P is an exterior angle. Now don't forget that we are looking at this these as two triangles. This is a triangle, this is another triangle. So if you look closely at triangle AXO or AOX, you'll see that there's an exterior angle. This is what I'm talking about, right? You'll see something like this, right? And then you'll see that this angle, the angle at P, right? This is what I'm talking about. This is P, right? This is angle P. This is A. This is X, right? Can you see that? Now, this point here is point O. So if you observe closely, right, you see that angle P is an exterior angle, right? Exterior means outside. It is outside the triangle. Now, the angle at A is X. The angle at X here is X, small letter X. And this is an isosceles triangle, right? Base angles are equal, right? AO, which is radius, is equal to OX or XO. Now, what do we need to do about this angle outside? We are considering this angle. I mentioned earlier there are two basic theorems of triangle, right? That at this level you should have known. In fact, it's basic, right? Now, the first one, sum of angles in a triangle, 180 degrees. That's the first one. The second one is that the exterior angle, that's the angle outside a triangle. The exterior angle of a triangle, right, is equal. So here, what's the exterior angle? P, right, is equal to the sum of the two opposite interior. These two angles now, they are opposite the exterior angle that is facing it, opposite. So this is P. These are the two angles, right? They are facing it. Now, the exterior angle of this triangle is equal to the sum, the addition of the two opposite interior angles. So P is equal to x plus x, right? P is equal to x plus x. And what's the reason? Exterior angle, right, of triangle is equal to the sum of two opposite interior angles. So pay attention to this. So what this means is that P is equal to 2x. P is equal to what? 2x. Pay attention. Now, let's go to Q. Now, let me bring out Q. So, for triangle, let me draw it this way, all right, for proper understanding. So, you have this, then, so this is B, this is X, right, and this is the center, which is an O. So, this angle here is Q. I'm drawing it from here, right? So this is Q. Now don't forget, this is Y. Okay? This also is Y. This is an isosceles triangle. Now you also note what we have done here is what we're also going to do here. That Q is an exterior angle, right? And going by this theorem, Q is equal to 2Y, right? Q is equal to Y plus Y. The same thing, right? The exterior angle of triangle is equal to the sum of two opposites. So we applied the same thing we did here, right? The same theorem of triangle we applied here is what we are going to apply here. So the exterior angle Q, right, is equal to the sum of the two opposite interior angles. These two angles, right, are facing, they are opposite to Q, right? They are opposite to Q. So that theorem that the exterior angle of a triangle is equal to the sum of two opposite interior angles. Like I said, for the sake of this topic, right, I won't be able to prove this now, but maybe we are going to release a video, right, that will explain, how this is, right? We are going to explain this. So, but just, have this in mind, okay? Have this in mind for now. So, Q is equal to Y plus Y. And what is Y plus Y? That's 2Y. So, Q is equal to 2Y. Q is equal to 2Y. So, what do we need? Now, this is what we want to prove. We want to prove that P plus Q, right, is equal to 2 into X plus Y. Now, why this or how this? We are saying that the angle at the center of a circle, which is P plus Q, right, is equal to twice the angle at the circumference. Twice the angle at the circumference, right? The remaining part, of the circumference. And that's because this arc here has subtended this angle at the center. So the angle at the remaining part of the circumference, right? The angle at the center is twice the angle at the remaining part of the circumference. So here, now that we have P as 2x, we have Q as 2y, right? So we can say that P, right, plus Q is equal to 2x plus 2y. So P plus Q, right, factorize 2, because that's the HCF, right, into x plus y. That's factorization, right? Factorization. P plus Q is equal, right, to 2 into x plus y. So can you see that, right? The same thing, right? So we can now say that therefore, right, let's write this properly. Now, P plus Q is the angle at the center, which is AOB. AOB, right? That's the angle at O. AOB, the angle at O, right, is the angle at the center of the circle, is equal to 2. Now, x plus y is AXB, right? The angle at x is x plus y. AXB, that's the angle at x, right? So, how do we write this in word? I wrote it earlier that the angle subtended. Angle subtended by the arc or an arc at the center of a circle is twice the angle at the circumference. Twice the angle at the circumference. Alright, so I hope that lesson was effective enough to help your understanding and to help you learn better. I want to believe that you've gotten better than before. So if you have not subscribed, do well to do that. Subscribe, like, and share to everyone around you so you can get more notifications. Thank you. Bye.